Hi everyone, I'm Cheryl. In this problem, we're going to be using Lagrange multipliers to find the minimum distance between the line x plus y equals 1 and the point 0, 0. Now, in order to use the method of Lagrange multipliers, I need to first have a function that I'm going to be minimizing and then the constraint. So let's take a look at the function. So I want to minimize the distance. Well, the distance formula tells me that the distance is the square root of x minus x1 squared plus the quantity y minus y1 squared. This will get me the distance between any point xy and a point x1, y1. Since I want to see how close it is to the point 0, 0, in this problem, my x1, y1 is 0, 0. So this is going to be x minus 0 squared plus y minus 0 squared. Now, while I can minimize this particular function, it's actually going to be easier to calculate the minimum of this function squared. Wherever the square of this function is minimized, it turns out that the distance will also be minimized. So I'm going to look at d squared, which is going to turn out to be just x squared plus y squared. So I now have a function to minimize. I'm going to call my function f of xy equals x squared plus y squared. So that's my function. I also need a constraint if I'm going to use Lagrange multipliers. And my constraint is going to be the fact that my point has to satisfy the equation x plus y equals 1. So I'm going to write this as a function of x and y by saying g of xy equals x plus y minus 1. Okay, now for Lagrange multipliers, what I need to do is I need to look at the gradient of my function f of xy, set that equal to my Lagrange multiplier lambda times the gradient of g of xy. So my gradient of f is going to be 2xi plus 2yj. And on the right-hand side, I'll have lambda times the gradient of my function g. So this is going to be I plus j. All right. So now what I want to do is I want to make sure that the components, the I component on the left side is the same as the I component on the right-hand side. So let me write one more step out. I'll write that as 2xi plus 2yj equals lambda I plus lambda j. So that means that 2x and lambda should be the same thing. So 2x equals lambda. And 2y should also equal lambda. So 2y should also equal lambda. Now I need a third equation, and my third equation is going to be the equation x plus y minus 1 equals 0. That comes from the constraint. So now I have a system, 3 equations, 3 unknowns. So I'm going to begin by combining those two equations. Because 2x equals lambda and 2y equals lambda, that tells me that 2x equals 2y, which means that x and y are the same thing. I am then going to take that and plug it into my third equation. So when I do that, I know that x plus x minus 1 equals 0, which means that 2x equals 1, or x equals 1/2. And if x equals 1/2, I know that since x equals y, y is also going to equal 1/2. This will give me the minimum of my function. You can tell by looking at the function and its constraint that this will be a minimum instead of a maximum. All right, now this tells me where that minimum occurs. But remember, the problem asked me to find this minimum distance. And I actually minimized my distance squared. So when I go to calculate my minimum distance, I want to make sure that I plug it into the distance formula. So that tells me that the distance is going to be the square root of 1/2 minus 0 quantity squared plus 1/2 minus 0 quantity squared, plugging in the 1/2 for both the x and the y. So this will give me the square root of 1/2 squared, which is 1/4, plus 1/2 squared, which is 1/4, or the square root of 1/2. And if you prefer, you can write that as 1 over the square root of 2 for your minimum distance. I hope that was helpful.